This video will show you how to we'll review how to estimate the returns or generate the return columns, estimate some basic descriptive statistics, create a pivot table, and just look at the data and to see if the returns are approximately normally distributed. In the next video, we will use the functions to estimate probabilities using the normal distribution. So this data is Tesla and Microsoft returns. These are the two stocks that were used in the notes. So I'm going to use them just to be consistent. And this is 10 years of data. So from January 2015 through December 2024. So the first thing we want to do is generate the returns. And remember, it's always current divided by previous minus 1. So this is going to be for Tesla, B3 divided by B2 minus 1. If we drag that over, we'll get the same thing for Microsoft. And if we click this and drag that down or double click, it'll fill those in so we have all the values. And these cells are already formatted as a percent, 2 decimal places, but if they were not, you could highlight those, format those as a percent, and then 2 decimal places. So you could do it. You could do that either way. If it's not formatted, that's how you would actually do that. So what we want to do is estimate some basic descriptive statistics that we can use to see if the assumptions for the normal distribution have been satisfied. So we want to look for mean close to median, skewness and kurtosis close to 0. So the mean for Tesla is going to be the average. Remember, we always do this on the return columns, D:D. The median, we'll do median, D:D. Standard deviation is always sample. So if you start typing stdev, we want stdev.s, D:D. Skewness is just skew, D:D. And then kurtosis is kurt, D:D. Again, I already had these formatted, but if we did not have them formatted, you could highlight these three, format those as a percent, 2 decimal places, and then you'd highlight these and format those as a number, and then give yourself 2 decimal places. And that would give you the correct formatting. And then we're going to drag that over. So now we can compare the Tesla and Microsoft returns. So for Tesla, the mean was 4.34% with a median of 1.18. So the mean's significantly larger than the median. For Microsoft, it appears to be much closer. So the mean and median for Microsoft is a lot closer. The mean and median for Microsoft are a lot closer than for Tesla. We'll use the standard deviation later, but we can see that the standard deviation for Tesla returns is significantly higher, almost 3 times higher than that for Microsoft. So higher return, but also a lot more volatility. Skewness, again, there's no threshold here for what is close to 0, but we can see for Microsoft, we have less skewness and less kurtosis, which is telling us from this at this point that the normal distribution may be a more reasonable assumption for Microsoft than it is for Tesla. One of the easiest ways to actually check for that normal distribution, again, it's not telling us that it is normal. We're just seeing if it's reasonable to assume a normal distribution when we make inference. So what we're going to do is create a pivot table for Tesla returns, and we'll create another pivot table for Microsoft returns, and then we will plot those, plot the distribution of the returns and see how well if they look approximately normal. So the first thing we want to do is highlight the Tesla return column. We want to insert right here. We always drag the return into rows and the return into columns, but we have to double click that and change that to count. This is not helpful because it's continuous, so we only have every value only shows up once. So what we want to do is group this. Actually, let's just plot it first. So if you click on in the table, insert, go up here where it says column, click the first one. Again, not helpful because everything is going to show up exactly one time. We're going to right click in the row labels. We're going to group this, and instead of grouping in increments of 10%, let's group these in increments of 2.5%. So we're going to go 0.025. So 0.025 would be the same as 2.5%. And okay, then there's our distribution for Tesla returns. We can see that we have these values hanging out up here to the right, these large positive values, and that's what's making this mean, that's what's pulling this mean above the median, which gives us that skewness value that's also positive. So this, we would say this is skewed right. So let's create another pivot table for Microsoft returns. Trying to combine these into one, it's a hassle, so we're just going to make two separate tables. We want to make sure we put it somewhere else so that we can put both of these on the same sheet. So here's our pivot table for the Microsoft returns. So we're going to drag this into rows, drag this into the values, change this to count. And we want to use the same bin width that we used here. So for this one, we used a bin width of 0.025, so 2.5%. So let's do the same thing over here. So let's right click inside of there, group, leave those alone. You don't have to change those. Change this to 0.025. So notice the range is significantly smaller here than it was for Tesla. Here we're getting negative 36.7% on the minimum and 75% on the max. Here we're getting about negative 11% on the min and about 22% for the max. So if we just click anywhere in this table, we're going to go to Insert, go to Column, click the first one, and these are going to be your returns for Microsoft. Again, not perfectly normal, but it does appear to be slightly more symmetric. We have less of a long right tail than we did for Tesla. None of this is proof that it's normal because it's clearly not not perfectly normally distributed. But if we're going to think about using the normal distribution to estimate probabilities, our numbers may be more reasonable for Microsoft than they would be for Tesla. So just have to always inspect the data before you work with it. If you just go straight into doing some analysis without doing some basic exploration of the data set, you could get yourself into a lot of trouble. So that's all. I want to stop that video here, which is plotting those distributions and checking for normality. In the next video, we'll actually use, we're going to assume normal, even though it's incorrect for Tesla, very incorrect for Tesla. We're going to assume the normal distribution and estimate some probabilities.